Hello and welcome to one of the last talks. Before we really get started, what I wanted to kind of walk you through is kind of some applications that we would typically write today. And what do they all have in common? So for example, if we had a game such as this, what is it really doing? Well, let's see. We have a time loop where we're obviously reacting to events here. If I can actually figure out what I'm doing here. All of these sorts of things. We have timers, we have animation, we have all sorts of things, whether it's that, even edge detection, for example. What do these all have in common? You know, even simple things like coordination of events together, or real-time data analysis. Or for example, just a simple drawing mechanism. What do all of these have in common? You know, even anything like Super Mario Brothers, or to-do MVC. So hopefully that will come true, and I can knock that off my list. But text editors, animation. And even video players, for example. What do these all have in common? You know, this, for example, streaming live data. Really kind of cool kind of thinking. But all of this is based upon, and then especially here, is based upon a very, very simple concept. And that is the observable. And reactive programming, which we will talk about today. So, as I said, there are a lot of different ways about thinking about these large applications that we're building today. And so what we're going to be doing is really talking about how some of the larger corporations in the world have solved some of the really hard problems in a particular way by thinking very differently about how they write their applications. Whether it's Netflix, Slack, or Microsoft or anyone else, they all have the same problems that you all do. But they thought very, very differently about how they did it. So if you want to follow along at home, you can do so there. The slides are available now. Now, the way I always like to start off with a talk is just to kind of give an alternative title. For example, how I stopped worrying about asynchronous programming and started to learn to love the observable. So like I said, it's going to be a little bit of a mind shift on how we do that. And just because I love concurrency jokes, and who doesn't, or I thought to myself, I'll solve my problem with promises and events. Have now problems 2I. Dang. So many people may wonder why I'm wearing this hat. Well, I am a principal software engineer at a fairly large company. But why I wear this hat is because I call myself an open sourcerer. And what I mean by that is the fact that for the longest time at Microsoft, I've been doing open source in such a way that I've worked on such initiatives as getting Node supported on Windows to open sourcing a large part of .NET. And that's been a lot of my behind-the-scenes work at this particular company. And yeah, I love that logo. I really wish we had that one still to this day. But this one is from 1981. It's a real logo. But I like to think of myself as putting a little bit more metal into Microsoft. So if people saw me last night, I was talking about this particular project. So if people want to talk about running Node on phones, you can come and talk to me afterwards. I think it's a very interesting project about building the pure web, and I think it's very, very applicable, especially at conferences when Wi-Fi can be scant. But the vast majority of what we're going to be talking about here is my work on the reactive extensions. Now, this is a thing that we've been working on since 2009 at Microsoft, and really it's a fundamental shift on how we think about asynchronous programming. It has its own history in which we were trying to solve problems with asynchronous programming before a lot of people actually had those problems. This is 2009, before promises really existed. We were trying to invent our own style of how we were to express both events and asynchronous callbacks in a simple way. And so what we called ourselves is we were a part of a larger program called Volta, but we then shorten ourselves to Reactive Extensions, or we just call ourselves RX pushers. Now, what I really want to talk about is Netflix in particular. And how many people have Netflix? Heard of Netflix? A fair number. So their goal is fairly simple. Stream movies from any device. And if you think about it, at scale, you're talking a lot of data. You're talking 1/3 of the U.S. broadband traffic. I don't know what it is in other countries, but that's a significant amount of things that they have to worry about. So this is really a story on how Netflix, Microsoft, and others have solved some really fundamentally hard problems in building those large systems by just thinking a little bit differently about how they deal with events. So for anyone who actually has the Netflix player, it's fundamentally asynchronous, everything about it. The last thing you would want to do is have that little spinny thing of death that Christian was talking about in terms of error handling and so forth. So everything, app startup, the player itself, animations, and view model binding is all done asynchronously. No blocking involved. But that introduces a good number of problems that you're going to absolutely have when you're trying to do that. Whether it's memory leaks because you have so many open event handlers to race conditions where these two events have to happen in a certain order, or this asynchronous callback has to happen in a certain order, that can be very, very complex. And not only that, but this notion of callback hell is very, very real. And it's not just because your code is walking off the side of the page. It's more along the lines of you're building these very complex state machines, and you're not quite sure exactly where you are in the code, because somewhere within all the callbacks is your state, and you're not quite sure where you are in the computation. So in 2014, they finally did a complete and utter redo on where they were. So when they started in 2011, they had 7 different platforms, 7 different languages, all to describe doing these asynchronous operations, as I showed you. Each one had its own way of thinking about it, for the data binding, for the data access, and so forth. And so what they did is they thought differently about how they were doing events so they could standardize on a single way of thinking about it. Not just having one library, 2 libraries to do it, but just thinking fundamentally different about it. And so what they came up with is using the observables, which we'll be talking about today, as their base. And what this is it's a very language-neutral approach to solving asynchronous problems. So what they were able to do is port what we've done already in JavaScript and .NET to other languages such as Groovy, Scala, Java, Clojure, and so forth. So regardless of whether you were a front-end developer or a back-end developer, you could easily switch between teams because you understood the paradigm. It wasn't necessarily that you needed to understand the language, you understood the paradigm, you understood the architecture. So quite honestly, why is this so important? Because real-time is everywhere in what we're doing today. Whether it's looking off of your phone and getting GPS data, seeing where you are, SMS traffic, any number of these sensors, Twitter notifications, anything. How do you keep up with that? And how do you coordinate them all together without just giving up and just shoving them down your shirt? It gets very, very complicated very, very quickly. And unfortunately, the given mechanisms that we have in JavaScript are terrible. Let's just face it. I mean, programming asynchronously in JavaScript today, using events and using callbacks and using promises aren't exactly great. They might be better in the future, but right now, it shows an utter lack of coordination here. I don't know why the guy couldn't just put down one thing and oh well. So it even was a topic of concern, even to the highest levels of the U.S. government, for example. So President Kennedy said, we choose to solve asynchronous programming and to do other things, not because they're easy, but because they are hard. And then he realized afterwards, after saying this, he was like, well, maybe it is too hard, and let's just go to the moon instead. So he decided to go to the moon, I think. So, like I said, callback hell is really a thing, and like what I meant by that is the fact that we have here, whether you're having a movie ticket and the player error, and then you're trying to figure out where exactly are you. Okay, if the player is not initialized, then initialize it and then try to finish. Okay, going in to try to finish, then where are you supposed to go from there? Oh yeah, you're supposed to go to that callback, which might be authorized movie. It just gets very complex, and it turns into, instead of the pyramid of doom or anything like that, I call it a cow's head. And I think it's very, very easy to get burned on those kinds of things because you have no idea where your status is, where you are in the computation, and if you're looking at your stack traces, you just get lost, and it makes me want to jump out a window sometimes, quite honestly. And even when we're dealing with raw events by themselves, we still have to have whether the mouse is down or not, and the state that we happen to deal with. Well, what if we want to go beyond that? What if we want to add some delays to it, or call make an AJAX call? All of that then gets somehow lost because now you're having to deal with all of these 3 separate callbacks and having to decipher where all of your logic is going to be. So yeah, whoops indeed, it really is an enemy of the state. And like I said, all of these events that you're trying to coordinate becomes very, very hard to juggle, quite honestly. So in our infinite wisdom in JavaScript, we came out with this idea of promises. So we would have this first-class notion of instead of dealing with callbacks, we would deal with promises. So then we could take the aforementioned example, and we could say player initialized, then authorize movie, or else it's a login error, then play the movie, or it's an unauthorized, you're not allowed to do it. But you have problems with that. And the problem is the way that it was designed in ES 2015, or ES6 as some people call it, is the fact that there's no cancellation built right into the promise itself. There isn't any. You can certainly write it yourself, but by default, it isn't in there. And in fact, it actually became very much a point of contention when people were starting to use the fetch API and realizing that they were using the XHR like everybody else was used to. And then they're like, well, so how do I cancel that? Oops. So they kind of left that out, and so this is a fairly long thread here, as you can see, 21 participants, and 204 comments. So I think that kind of solves the problem of how many engineers does it take to cancel a promise, and they still haven't figured it out. And not only that, but it also lacks a notion of finally. So for example, if you have some sort of resource that you want to finally clean up at the very end, ensure that at the very end of your chain is going to be cleaned up, there isn't any. So what I considered is that the promise itself is a very nice way of dealing with a really fast car with absolutely no brakes. Now, other people think about stream programming and think, well, that maybe will solve our problem. But when people think about stream programming, they mostly think about node streams. And quite honestly, in the beginning, I would say that node streams were pretty terrible. In the fact that, just like that poor kid, the data started firing before he was ready for it. and you couldn't consume just a little bit, nope, you're completely screwed, because pause and resume were absolutely hard to get right. And so they had to come up with 4 different ways of expressing streams in the next version of Streams 2, with transform, readable, writable, and duplex, yay. And then Streams 3 still adds more complexity with whole bulk writes and bulk reads. So once again, very, very complicated stuff in order to do something that should be fairly simple. So let's go back to 1994. I realize probably not many of you were born by then, but let's go back anyways. To this particular book here, Design Patterns. And this is a hallmark book that a lot of people bought, because it was this idea where you took all of these design patterns and finally put them in a single book together. And what they did is they had so many of these patterns, whether it's singleton, facade, abstract factory, all those things that you use for your Java names for particular classes. But 2 in particular that were very interesting to at least me at the time and us was the iterator and the observer. But there was absolutely no linkage at all between the 2 of them, but we thought that there absolutely was. So for example, in the iterator pattern, which is now as part of ES 2015, we can say get numbers, which returns us an iterator in which we can call next, which tells us whether we're done or not, and gives us our value. So we can go through there, and finally we get done, and value is undefined. And the subject observer pattern, which we're all very, very used to, for example, on document add event listener and remove event listener, is the subject observer pattern. So we've been using these design patterns since forever in JavaScript. And so when you move the mouse, sure enough, you started to get the data. Now let me ask you a fundamental question then. What's the difference between an array of this kind of data and that mouse movement we just saw before? Well, they're both collections. Nothing more fundamental than that. And the fact that your mouse, your phone, and an array of stock ticks are both collections that you should be able to treat as just the same kind of thing. And as was talked about yesterday in the functional programming talk, when you talk about functional programming over these collections, that's exactly what we're going to do here. So the vast majority of the coding that was done that I'll show you is all using very, very few functions, but very, very powerful ones. For example, map, which is the idea that you can transform every single element in the collection and project it to a new collection. So in this example, we can take our circles and project them into diamonds. And the same thing with filter is to apply a predicate to every single item to say, I only want circles, so give me circles. Now, flat map's a little bit different, and it's a little trickier to think about. Although if you're used to arrays, it's no more than just a Cartesian product, but that's not good enough, quite honestly. But what it's really doing is it's going to do a map like we showed before, and then it's going to start merging the data back into a single stream. So it's going to start getting multiple pieces of data, as you can see here. For example, the red here will project down into multiples. So it starts based upon the time and the reacting to merge it all into a single stream. So yes, I realize it's a fundamental shift in the way that you're thinking about it, and you really kind of need a smack to really kind of think about it a little bit differently. So let's actually walk through some code and make it absolutely clear on how this works. So if I wanted to get the top-rated movies, what do I do? Well, I start off with the array of the video list for a particular user. I go through and I filter out all of the ones that I only want the ones that have the rating of 5. And then I can go through and pass in myself and display each movie. Now, what if I told you that I can turn that exactly around on its head and say I can create a drag event with the same exact code? Would you believe me? Of course you would. Well, why would I be here? So what you would do is you would take the mouse down and flat map, or just the map and the merge, and then take the mouse move, take until mouse up. So basically what you're doing is you're saying mouse down and mouse move together, merge together, and take until mouse up happens. And when mouse up happens, the collection stops. It no longer is a collection. Now suddenly you get that Zen-like feeling. You're like, wow, just about everything that I'm dealing with is a stream. It's something that I can query, something that's very tangible, unlike events today in JavaScript. Why? Because it's a first-class value. And what I mean by first-class value is the fact that I can both create one in a method, but I can also return one as well. And where does it really fit into the grand scheme of things? So when we talk about the general theory of reactivity, as it were, we have 4 quadrants here. Whether it's single or multiple, synchronous and asynchronous, we just have to think about each one a little bit differently. So for example, an object is fairly straightforward. In ES5, we added in the ability to do filter and map directly on our arrays. So now that we're able to do some fairly good compositional programming styles using just plain built-in objects. Then the promise came along as part of ES 2015, although it had been around for quite some time before that in various forms. But then we now have a notion of a single value. So instead of having to deal with a callback, we have this single value I can hand around to everybody, and they would get the right value. Now, observable, on the other hand, looks exactly like array. And there's a very specific reason why, is because in order for people to actually start thinking about asynchronous programming, you want to give them something they're familiar with. And let me just clear something up, that observable is definitely not object observe. It's not an event emitter in JavaScript, nor is it an event target. And just as well, object observe went bye-bye anyways. And that was the thing that people were like, oh, this is great. We're going to solve all our data binding issues with object observe. You know, I'll change something on there. No. It ended up being a pig. It ended up being very, very slow. So it's gone. So instead, everyone started to hop on this idea of reactive programming. And unfortunately, when I say reactive programming, everyone said React. Crap. Yeah, never mind the fact that there's nothing to do with reactive programming in React, but you know they kind of stole the moniker I've been using for 5 years. Oh well. So what is reactive programming, anyways? So you know it's a very squishy term, sort of like the way that functional programming is a squishy term. You can't quite define it very easily. So I just went to the dictionary. Why not? Because Wikipedia had this really long article and I couldn't figure it out. So it just says readily responding to a stimulus. Okay, and its components are active and always ready to receive events. Well, we've already done that. Gee, jQuery has been doing that forever. And even further than that, I think our business analysts in our company can laugh at us easily, and they're like, You noobs, we've been doing reactive programming forever. It's called Excel. So you really want to know what reactive programming is and where it came from. There's actually a paper that people can read on the very origins of reactive programming by Gerard Berry, about how he created the general purpose language for doing so. And yes, I know there's a certain phobia of reading academic papers because they have a tendency to make you melt in terms of their content. And even the smartest of us have that kind of reaction to technical papers. And and God bless the Germans for coming up with an exact word for this, of Computerwissenschaft akademische Paperphobie, I think. There you go. I love it. Yes, I love having a German in there. I love you guys that you can shove 10 words into one. Anyways, so yeah, there's an actual, I think, term. Maybe I made it up. I don't know. And when people start to talk about reactive programming, they start to think about functional reactive programming. No, 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 no. This is not what people are doing when they think about reactive programming. Functional reactive programming is a very precise term. It's a term that comes from Connell Elliott and Paul Hudak from the 1990s in a language called Fran. And it had very precise meanings for everything that they did. And they called it FRP, so we're kind of stuck. So they had a very distinct notion of separation between time, continuous time, whether it's a clock versus discrete events, and it's just not important. So, call us whatever. Compositional event programming, reactive, don't care. But what I want to get to you is the fact that we have a very precise way of thinking about asynchronous programming, because you have 0 to infinite values, either terminated by an on error or uncompleted. And it doesn't have to be, obviously. You can continue infinitely. You could emit a couple and have an error. You can complete. But what you could never do is you can never have anything overlapping, and you certainly cannot get values after it's been done. So type-ahead search is one of the most difficult things that we've ever done. I don't know why, but it just seems that everybody tries to re-implement it and doesn't do it very well. So I decided to implement it in jQuery. Yeah, just jQuery. I had to add it to bounce. I had to add some checks. I had to add in the XHR and retry. So I wrote more and did less. So instead, I go, I can solve this a little bit better. What if I could say, take the DOM in key ups, bounce it by 500 milliseconds, distinct until changed, did a search, and bound directly to the UI. Done. I think I just eliminated 3 pages of code. Now, we've already kind of talked about what the observable is in terms of that contract of 0 to infinite values. But let's actually go down to, and we've already talked a little bit about map, filter, and reduce. So let's actually go into something a little bit more complicated that a lot of people do with their web applications. So for example, if you're dealing with a phone or you're dealing with something that's constrained in terms of how much memory and how much storage you have, you want to be able to only keep on the screen what's absolutely necessary on the screen. And as soon as it goes off, you want to completely get rid of it, get rid of all its handlers, and leave nothing around. How do you do that? Well, first off, you're going to listen for the document scroll, and then you're going to debounce it just a little bit, just in case people start to scroll up and scroll down rapidly. And then they're going to basically determine, based upon the row visibilities, determine whether it's hidden or not hidden. And then what you're going to do is you're going to take your row shows and do a polling, basically, and you're going to get the row data, continuously get that row data, until it tells you to hide it. And as soon as it tells you to hide it, everything goes away. Everything. So it's really a complicated kind of thing, and people can look at the code afterwards. But I think it's very magical in the way that they were able to think about it in very precise terms using functional programming and reactive programming together. Just like our callback hell example, we could actually go a lot further than we did with promises by actually going down here and authorizing and retry 3 times if it fails. And then we can also say, if the person goes, oh gosh, no, cancel, cancel, cancel. Well, we can automatically stop that with take until. So it's a little bit more than the burning sensation that we got from callbacks. Now, Slack, for example, Slack for Windows uses RxJS. And what they use it for is very, very complex kind of interactions, like an editor should. Like, for example, if they want to implement spell check, what do? I'm not going to explain all of this in particular, but I just want you to understand that they are actually determining your language as you type, and being able to do that very, very easily using this technology and thinking differently about events. Now they are able to think about these things as objects and pass them around. And as Europe now allows us to think about, is now try catch finally becomes very easy, because I have catch, in which I can retry 3 times. I can catch and return some default data. So, for example, if I'm creating an offline first application, I can try and get the data, and if I fail for some particular reason after 3 tries, then I can just give them some default data and say, here you go. And then finally, at the very end, I can do some data cleanup. Now, data back pressure is also a thing that people like to talk about, and yes, observables can absolutely do that. In fact, we're working on a standard for exactly that. It's called reactive streams. Now, it's even more important that you want to win friends and influence others. So obviously, you want to work with the React, Angular, and Ember communities to see how observables mix with them. And so what we've been finding in the community is that there are literally 26 different implementations of Flux written in observables. And there are about 27 or 28 different bindings to React directly from observables. Now, Angular is its own special little beast. And why that is if you're going to use Angular 2 at all, then congratulations, you're going to be using observables, because the HTTP stack itself is an observable, is RxJS today. So they've already added that in, and what people have been finding is that people want to use those 2 things together, because it solves a lot of their problems. They have the retry logic, they have the catch, they have the finally, all the things that the promises could never give them. Now, what's also very interesting is not only is it really interesting for just doing the basic kinds of things, but I would say that our notion of having this swappable concurrency layer is also very interesting. So schedulers to me matter in the fact that what I can do is I can say where, how, and when something is executed. So for example, I can take an observable and I can generate using the default asynchronous scheduler. Well, that's a problem in the fact that, oh geez, I just completely turned my machine into a helicopter, because the fan is just going to go completely off its rocker. But instead, if I could do something like the request animation frame scheduler, then it changes how the picture. Apparently, I didn't swap out the picture, but anyways, it absolutely does matter, because now you decided to use, instead of set timeout or any other request set immediate or anything else, you've now decided to move it to a request animation frame. So when I said that Netflix is using it for animations, that's exactly what they do, is they take a lot of their asynchronous operations, throw it onto request animation frame, and all they had to change was 1 line of code. They didn't have to go completely throughout their infrastructure to do that. Now, async await is very interesting in that it makes programming very, very easy in a very imperative style. So I can do try catch, and I can treat it almost as if it were asynchronous code, which is absolutely beautiful. It's actually a stage 3 proposal right now for ES 2016, or ES 7 as people call it. And it actually ships in the Microsoft Edge browser today. So if you have Windows 10 and Edge, and you can turn on experimental features, it's there today, which is kind of cool. Now, with observables, you get also that same kind of thing, is because what we have added is basic support for async await. So I can say, when the text changes, I can call an async function on text and await the search result, which happens to be a promise. So that, to me, is kind of cool. And so I think it has a lot of promise, especially, oh God, I just said promise. Anyways, so instead what we're going to see here is that observables are in fact coming to ES 2016. So if you go there, somehow something happened with my slides, but observables in ES 2016 are absolutely coming. That hopefully that they're in stage 1 right now, and we're working towards stage 2 of adoption. But the idea here is that we will now have complete and utter support for observables in your browser directly. So now you'll be able to do a lot of the things that that, for example, that Netflix and others have been able to do just by using your browser directly. That's kind of cool. Now, let's talk about the future a little bit. So the future is very, very interesting, and the fact that we have right now at Reactive Extensions RxJS, but in the future, we're moving to ReactiveX, and in fact, all of the code that's being done right now is a combination of Netflix, Microsoft, and Google all writing this together. Who would have guessed that in 5 years ago, that someone would say that Microsoft and Google and Netflix and even Facebook are writing a library together? Well, it's true. Yesterday, during the functional programming thing, there was a comment about RxJS versus or CSP versus observables. So I don't necessarily want to dog one or the other, but yes, observables can absolutely do everything that CSP can do. So let's go back and take a history lesson here. CSP was created by Tony Hoare, who works for Microsoft Research, no less, in 1978. And he wanted it for production systems where they were kind of loosely coupled. Why it was mentioned in a functional programming context, I don't know, because there's really nothing much functional about this. There's a while loop, there's a global channel, there's mutation all over the place. It's not really functional. So the imperative cat is not amused because, like I said, it's a different definition of simple to me. I don't find this whole thing of a while true loop to be all that simple. And in fact, when I think about the composition, I think of that as a lot more simple, quite honestly. So maybe it's a personal thing. But why observables? Why not CSP? Well, for example, I have deterministic cleanup. So for example, if I create an observable here, I not only get the on behavior, which I'm sending next values, but also when I return an object, I give it this handle in which I can tell you to stop. And when I tell you to stop, it removes that event handler. And so when I start listening here, and then when I call unsubscribe, that handler goes bye-bye. In CSP, that doesn't work that way. Also, in CSP, you have a notion of there's no consistent error handling at all. So instead, you have to throw it off to an error channel, and hopefully you can listen to it. But instead, here we have an error channel that's built directly into the pipeline itself. So it's very easy to think about it when we can listen to it on our error handler here, and we can also try and retry here and catch directly into there. So with that, I don't know, do I have sound here? Apparently I don't. Oh well. Anyways, so if I can leave you with anything today, I want to say push. Think about push collections, think about events very, very differently. And so with that, I'll be glad to take any questions.
Thank you, Matthew.
Could you explain a bit about the difference between Rx extensions and other libraries out there like Bacon.js or other things that deal with reactive programming?
Okay. The question was, how does this differ from any other library that does reactive programming? Well, certainly RxJS was the first one out there, since we've been out since 2009. There are slight differences when you talk about bacon and so forth. None of them have the, for example, the virtualization or notion of a virtual time where you can just swap out the scheduler. They don't do a lot of that. Instead, they tried to focus on simplicity in terms of really, 0 to 60 really, really quickly, instead of a more comprehensive approach which we took. And there are a few fundamental differences on how we thought about hot versus cold observables. It's a long discussion. You can come and talk to me afterwards. But there are some fundamental differences on how we tackle those problems. But that's mostly for the most part. And we're fairly friendly with one another in terms of, we're always trying to one-up another in terms of speed, in terms of features, and so forth.
I have heard of a lot of people complain about a document of RSS. It's too complicated, especially for a beginner. So do you have any plan to fix that?
In terms of stuff for beginners, well, we have a lot of exercise. So if you go to Reactive.Io, which is our homepage, and let's see, is it still up? Oh, it's directly on me. So anyways, if you can go to Reactive.Io, and take a look there. We have a ton of material in terms of our introduction material and so forth in terms of why to use them. But also there are lots of other interesting things such as Reactive.Io, LearnRx. There are interactive exercises there that you can learn. If you go to Egghead Radio, Egghead.io and Technologies RX, there are a ton of material there as well. So in terms of approachability, the internet is fantastic here, by the way. Sorry. But if you go to these particular sites, Egghead Radio has a lot of stuff that is particularly about new people coming to RX from nothing at all. Explaining the very, very basics. Here, I wanted to get through the fact that, yes, I could have done a very introduction talk, but it's more along the lines of showing the real power of why people are using it versus the, you can do simple autocompletes.